This week, we welcome back Marcelo Salvati. He's a security analyst at our sponsor, of course, Black Hills Information Security. He's going to give us some updates on his post-exploitation tool, SILENTRINITY. Shh, 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 silent. In the second interview, we welcome Steve Brown. He's the keynote speaker at Secure World Boston 2019, and he'll be discussing his talk all about building your strategic roadmap for the next wave of digital transformation. In the security news, password managers are leaking data in memory. Security analysts are only human. Splunk changes position of Russian customers. Google admits error over a hidden, air quotes, hidden microphone. And a nasty code execution bug in WinRAR that threatened millions of users for 14 years. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Organizations' internal networks are overly permissive and can't distinguish trusted from untrusted applications. Attackers abuse this condition to move laterally through networks, bypassing address-based controls to spread malware. Edgewise abstracts security policies away from traditional network controls that rely on IP addresses, ports, and protocols, and instead ties controls directly to applications. Edgewise allows organizations to analyze the network attack surface and segment workloads based on the software and how it's communicating. Edgewise monitors applications and protects data paths using zero-trust segmentation. Visit edgewise.net/securityweekly to get your free month of visibility. Some restrictions apply. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then Gravwell is the solution for you. Gravwell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. Gravwell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/securityweekly for an unlimited data trial and gain uncompromising visibility today.
And welcome to the show! But first, let me introduce you to a man who is a fan of lots of things, including tacos on Tuesday, Mr. Paul Asadorian.
Welcome to Paul's Security Weekly. This is episode 595. We're recording on February 21st, 2019. We are in G-Unit Studios in Rhode Island, and by we, I mean myself and the illustrious Larry Pesce is here.
Yes, I am.
Talking about our network woes. Yeah. We both did some recabling lately.
Yeah. Mine because I ripped out the floor in my office and put new ones in and looked under my desk and went, what the hell happened?
Right? Like physical infrastructure is still a thing. I feel like we get caught up in talking about cloud and containers and serverless and all that stuff, but like there's still you still have a computer,
right? And power
and DNS servers. I mean, those are important.
Yep. And like maybe cables to your monitor if you use those.
Yes.
And,
still that stuff is
UPSs, power strips.
Absolutely. Welcome to my world.
Yep.
On the lines remotely, we've got Lee Neely who wants to comment on physical infrastructure. Welcome, Lee.
Hey, good to be here from snowy Idaho, and don't forget while you're setting up your computer infrastructure to have your zombie defenses ready as well.
It's very important.
Like your chainsaw.
Wait. Attenuation by chainsaw? What?
And fire extinguishers by the exit. Very important. So you can escape.
Yes.
My HVAC guy here walked in. He's like, "Well, you got a fire extinguisher? That's great." It's like, but it's like in the corner over there. He's like, "How is that going to work?"
Yeah.
I'm like, "Oh yeah, that's why they're at the exits. It's important." Also on the lines from the massage parlor, Mr. Jason Wood is here with us. Jason, welcome.
Hey, good to be back with everybody again.
Yes, nice to have you, my friend. Also from the wine cellar, I guess, drinking a martini, Mr. Matt Alderman is here. Matt, welcome.
It's a Manhattan.
Manhattan. I was going to say, once I saw the color, I didn't see the color. I just saw the glass. Yes.
Yeah, no dirty martinis until next week when I'm back in studio. But
oh, sweet.
Bourbon tonight.
Nice, nice. I love dirty martinis. Is there anyone else? Joff, I was going to say, there's someone not on the screen.
Dirty.
Yes.
Speaking of dirty.
Speaking of dirty, Mr. Joff Dyer is here with us. That's a great segue, Larry.
Wow, what an intro. He was going to totally leave me out. So it was Dirty Vespa. That was what I was thinking of.
Oh, yeah, those are good, too. Those are hard to make. That's I find a very difficult cocktail to get right. When you get it right, it's very rewarding. Getting it right takes some trial and error. And if you don't get it right, it's really bad. Like, it tastes horrible.
Yeah,
I've made some bad ones.
When you do get it right, you go running around downtown Boston telling everybody the new Joff Me Off recipe. The Dirty Vespa.
We need to bring some of those cocktails back. We all do have cocktails named after us. Most of us, anyway. All righty. RSA conference, of course. I know RSA is getting closer when I look at my inbox. It is just flooded with all kinds of requests to events and briefings and talks and announcements, all kinds of stuff happening at RSA. Of course, March 4th through the 8th. You can go to rsaconference.com/securityweekly-US19. Register using our discount code 5U9SWFD. That's 5 uniform. That's Fiver uniform 9er Sierra Whiskey Foxtrot Delta. Get you $100 off the conference pass. You can also book a briefing with us at RSA or InfoSec World. I think even Black Hat is up there if you really want to get ahead of it. But all you have to do is go to securityweekly.com/conference request. There you can request a free briefing with us. Matt and I have a long list of briefings to start going through and picking and choosing which ones, as not all are accepted. It's based on the discretion of the hosts/analysts that are attending. In RSA, it's going to be Matt Alderman and myself. You can also book a paid interview as well, and those will air on Enterprise Security Weekly, which is a great opportunity if you're one of the 1,000 vendors that are attending RSA and you want the security community to actually hear what problems you solve and how you do it. An interview with us is a good thing to do. securityweekly.com/conference request.
Hey, Paul.
Yes.
I think we're close to 90, and we're closing down submissions on Friday at 3 o'clock Eastern.
Gotcha.
So that's tomorrow at 3 Eastern time.
Gotcha. So get in while you still can. Marcelo is here with us. He returns to the show. He is a security analyst, a security consultant, rather, for Black Hills Information Security. Of course, you can go to securityweekly.com/BHIS. That's securityweekly.com/BHIS. And that will take you to their landing page where we're going to archive all of the technical segments, include extra little tidbits of content and cheat sheets and slides and all kinds of goodies there at securityweekly.com/BHIS. Marcelo, you're back this evening to talk about Silent Trinity, which is an ironic statement in and of itself, but you're here nonetheless to talk about it. See? He's silent. See?
Awesome. Right. Marcelo, microphone. There it is.
I did it. Okay. Yes, not anymore silent. Yes, I'm back, and I'm glad to be back.
So, Marcelo, we've received a lot of great feedback about your previous segment. Security Weekly listeners can go back and listen to where you described that. Go to the landing page, and we'll have links there, securityweekly.com/BHIS. That way you just have to remember one URL, and you can check out Silent Trinity. I have to say that when I talk about the techniques that you have implemented in that project, Marcelo, a lot of the security vendors that are providing defensive tools, it's an interesting conversation. I don't want to say there's no coverage, right? But it sparks very interesting conversations about how security tools are being implemented, more importantly, how they're being configured today.
Yeah, absolutely. And hopefully this time around, I'll do a much better job at explaining like how the tool works in general. I've sort of been learning C# along the way as well. So when I was first on here, there was some things about C# and the way Silent Trinity did things that I didn't even completely understand because I wasn't really looking into the lower level aspects of .NET. So this time around, hopefully, it's my chance of redemption. So I'll hopefully be explaining things a lot better, and hopefully by the end of this, everyone will have an understanding of like how the tool works, and we'll also be covering some detection mechanisms as well that I've recently discovered.
Sweet, let's get right into it.
Awesome. Okay, so I'm gonna share my screen here real quick. If I can find the button for it.
This is where us hosts are supposed to fill time.
Yes, exactly.
Who's Phil?
Phil
McCracken?
He's a,
No.
he's a good friend of mine, Phil.
Irish
Yeah.
cousin.
Yeah,
Yeah.
I've heard.
And Pat also. It's my other Irish cousin.
Pat McCracken?
McGroin.
Oh, Pat McCracken.
They're cousins.
Okay.
They're cousins, Larry.
Gotcha. Gotcha. Well, I mean, it's Ireland, so they could have been brothers.
I think Marcelo has figured out how to share his screen, thankfully.
Oh.
Wait. Okay. Well, we'll just do it like this. Okay. So, before we start delving into like how the tool works, we sort of have to all be on the same page of some key .NET framework concepts. Just because to completely understand the way IronPython talks to .NET and everything, we have to understand like how .NET framework actually works, right? So we have the .NET framework, which is just a set of libraries and engines that allow Microsoft, or really anybody, to build a programming language on top of the framework itself, right? We also have a bunch of languages that Microsoft officially supports. So .NET languages that Microsoft officially supports. So like a perfect example of this is C#, PowerShell, VB.NET, F#, and a lot of others that I probably missed. So these are .NET languages. So these are officially supported .NET languages built on top of the Microsoft .NET framework. The thing is, there are also a bunch of third-party .NET languages, such as IronPython, Booleang, which is somewhat of a more like little bit lesser known .NET language, Iron Ruby, and actually a recent one that I've just discovered is JavaScript.NET. Now that I've been looking into this area, I seem to be able to find a new .NET language almost every other day. So like as the name would imply, like IronPython is just like a Python implementation on top of the .NET framework. Booleang is just like a...
Marcelo, .NET has been around for a really long time. It was some vulnerabilities, I think, early on in Microsoft's time with it. But it is essentially allows you to take a language and make it so that you can write a web application with it, right? That's the purpose of the framework.
Well, so not necessarily. So it can do that too. But I think at its core, what it's meant to do is just provide an abstraction layer for people to build programming languages on top of.
I got
so,
you.
like,
so not necessarily web enabled, but any language.
Yeah, like actual languages. So like it provides just like a set of libraries and APIs and engines. This is like a really high level.
Yeah.
Like I'm butchering this explanation, but like this it's essentially just like a way of abstracting a bunch of stuff so that people can easily implement languages on top of.
Gotcha.
Yeah, and so one of the key implications of this is that since all of these languages are built on top of the same framework, they are all interoperable with each other.
Well, that's interesting. So, like, each language has a set of libraries. I'm getting an echo from you, Marcelo. But each language has a set of libraries that basically hook it into the .NET framework so that they can do Windows stuff or web stuff if that's the application, right?
Yes, yeah, that's correct. But I think in this particular case, Silent Trinity, from Silent Trinity's perspective, the tool that I'll be demoing, the more interesting implication of this is that all of them are interoperable with each other, which means that you can embed these languages within one another, and things will just work. So
yeah, so you could embed multiple libraries from multiple different languages to put that in one binary, and then when it runs, you have all that functionality.
Yeah, exactly.
I got you.
And from like an offensive perspective, doing this, like, so the reason why PowerShell was such a rage, and still is to a certain extent, is that it provided so PowerShell was built into every Windows operating system by default. and it was a scripted interface to .NET. So like operationally, from like an offensive red team and pen testing perspective, that's sort of like the holy grail, because you have all of the power of the .NET framework, which allows you to go as high as you want, as low as you want, and allows you to do all the good stuff that as pen testers like doing, or red teamers like doing, like injecting shellcode and reflectively loading portable executables, that kind of thing, right? And it was a scripted interface to it. So you could take advantage of all of the advantages that a scripting languages has, like its reflective properties and all that stuff by default on Windows. Now, the problem is everyone started abusing this, right? And Microsoft at a certain point said, okay, I'm going to put a stop to all of this, and implemented a bunch of defenses in the PowerShell runtime. Now, another key concept to understand is that these defenses like AMSI, script block logging, transcription logging, like constrained language mode, all of these defenses are only built in the PowerShell runtime as of right now. Okay, as of right now, they are only built into the PowerShell runtime. They are not built into the underlying framework itself. Okay, so what that means is that in order to bypass all of those defenses, all you really need to do is just jump language, is just change .NET language. So this is why you see all of these tools coming out recently built in C#, right? Because people have just started saying, screw all this. I don't want to deal with any of these defenses. I'm just going to just code everything in C# because you can still interact with the .NET framework that way and not worry about any of the defenses that PowerShell has in place. And the thing is also is that since like you can do that with C# and they're all based on the same framework, you can do that with IronPython. You can do that with IronRuby. And the advantage of doing this with IronPython is that it's a scripting language as opposed to a compiled language. So operationally, like C# has a bunch of things that you have to take into consideration. You have to keep compiling stuff over time. There's a huge overhead in setting up a development environment. So like it's great from some aspects, but like a scripting language just makes things a lot easier. And this is really that the core concept that SILENTRINITY uses is because all of these languages are interoperable with each other. You can embed IronPython within C#. You can embed IronPython within PowerShell. You can embed IronRuby within Booleang within PowerShell within C#. Like you can do crazy stuff like this. And incredibly enough, like this is basically what we've been doing for a long time. Like this isn't something new. It's sort of like a new spin on something that we've been doing for a long time because we've been doing this already.
Marcelo, so you can write some IronRuby that interfaces with .NET, and inside of your IronRuby, you can call IronPython.
Yes, technically, yes, you can. You have to deal with some dependencies issue with like some assembly resolving issues, which we won't get into because that's like beyond the scope of this. But and Black Hills actually did an awesome webinar about this last week. I did a webinar about this last week that dived a little bit into the technical details of how to actually do this. So definitely, if like the viewers are interested in the more of the little technical aspects, you can definitely go see that. And hopefully, by the time this airs, it should be on our YouTube channel. But yeah, so essentially, that's basically it. So you can embed IronPython within PowerShell, and it'll work. You can also like do all this crazy stuff. So like the SILENTRINITY stager, PowerShell stager, is a PowerShell script that embeds a C# executable that the C# executable embeds an IronPython engine. So it's like 3 layers deep of embedding.
Right.
And it just keeps going on like that. And we've been doing this for a long time. We've been doing this in tools like Powerline or not PowerShell NPS. So it's just a C# binary, right, that embeds the PowerShell runtime. So you can just embed the PowerShell runtime within a C# binary. You can do the reverse. You can copy and paste C# code, paste it in a PowerShell script, and call this magic add type function that just allows you to call all of the code that you put into that C# class.
Now, Marcelo, in embedding these languages via .NET, how does that give you an advantage of evading detection?
Well, this is the thing, right? So all of the defenses right now are concentrated in the PowerShell runtime, okay? they're not built into the underlying .NET framework. So in order and there are no optics built into the .NET framework itself. So like the underlying framework doesn't have any optics built into it to allow like EDR solutions or really anything to hook into it and like see if any malicious code is running. It's just not, there isn't a way of doing that right now, with the exception of like some really hacky ways of doing things like ETW, which we'll get into a little bit if we have time. But like there aren't any APIs or optics in place to allow security solutions to hook into the underlying framework. Right now, all of the defenses are built into the actual PowerShell runtime. So the minute you switch .NET language, you're bypassing all of the defenses that are built into the PowerShell runtime because you're talking to .NET through another language, if that makes sense.
That's interesting.
So we've been doing this for a long time with PowerShell and C#, but you can do this with IronPython and C#. And that's exactly what Silent Trinity does. So at the core of Silent Trinity is the C# stager, which essentially just takes an IronPython engine, adds some like magic sauce to it so that you can run an IronPython script natively on Windows without actually installing IronPython, because obviously that would be like a big downside to it if you had to actually install IronPython. So it adds some magic to like the C# stager and embeds an IronPython engine, right? And that's exactly what Silent Trinity does. Now, before, like when I released this at DerbyCon, it was sort of like a proof concept code. I called it beerware. And it was essentially that for a long time. Recently, I finally had the time to actually add stuff that would make it operational. Like you could actually use it on a gig now, which is kind of cool. So first off, like the entire C2 communication is encrypted. So like the staging process and the C2 communication are all encrypted using elliptic curve Diffie-Hellman key exchange. So it uses public key exchange. It derives a shared key, all of that. Everything's encrypted. So that's great. It also includes Booleang support. So Booleang is another one of those .NET languages. The problem with using IronPython within a C# binary is that unfortunately has a very key limitation, which is you can't call low-level Win32 APIs unless you embed the standard library with it. Unfortunately, the standard library is like 8 megabytes. So you'd basically have like a C# binary, which would be like 9 megabytes that you'd have to drop on disk, which is not ideal. So the way around that is just to embed another language that has built-in support for that. So that's where Booleang comes in. So Booleang allows you to basically just import native functions dynamically import native functions through Booleang itself through an embedded C# binary. It just keeps, it's like engine inception. It just keeps going like this. Also, the CLI tab completes all the things now, because when you get a session back, you get this long string, which kind of sucks if you have to sort of type it all the time. And you can customize the check-in interval that the sessions check in to. And there's also now a help menu function, which kind of comes in handy if you're using it for the first time. So I'm going to demo this real quick, and let's see if I can. Am I still showing the slides?
You are.
Okay, let's see if I can change that.
This is where we invoke Phil again.
Yep, definitely.
Oh,
Good buddy, Phil.
Okay.
What do you think, Larry?
I don't know.
Are you using this on Pentest yet?
I have not.
Okay, I stopped the share.
We got
Let's
the
start
echo
the
going again too, huh?
Maybe that's what I did wrong. Okay. Okay, there you go. Okay, so now you should see my screen.
Yes, we can.
Hell yeah, brother.
Neat.
Yay, Phil.
And let's see if I can make this bigger. Okay, clear all that out. That's not, don't look at that. Stop. Okay, there you go. Perfect. All right.
I saw it.
Yeah. So once you download Silent Trinity, you just install it using this, like as you always would with like a standard Python program. It's got the concept, like Metasploit resource files. You could just like put CLI commands on each line of a file. So it does that as well. So I just have a little file here that just goes to the listener menu, starts a listener up, HTTPS listener up, and just goes over to the module menu. So that's essentially what that does. And don't ask again. This is interesting. Okay. I don't know what that is. Okay, so I'm just gonna start SILENTRINITY up, and I'm just gonna give it that resource file. And the font is really huge here, so it's not gonna look as pretty as it does. But we started a listener, and we're good to go. Now, once we do that, there are a bunch of stagers that we can use now. So originally there was just like the MS build and Wimic stager. Now there's the PowerShell stager, which you can use to like get a stager through PowerShell, as the name would imply. I'm just going to use the MS build stager because it's probably like the neatest one in terms of like its capabilities, because it's also a whitelisting bypass, and this was a method discovered by Subti. And the way you just generate the stager is really simply just with the generate command, and then you just give it a listener name. So I need to actually use the stager first. And it does tab complete all things, which is great. And we started a listener called HTTPS, so I'm just going to give it that. And there you go. So it generated our MS build stager, which is just an XML file that executes some C# code, which starts the whole staging process. And I already copied that file already over here, just because I don't trust demos. And to start it up, all you really need is to copy and paste the command that the server gives you here. So copy and paste that into here, and I'm going to also make this very big.
We're old now, Marcelo. We need big
Yes,
fonts.
We all need big fonts. And there you go. So now we're ready to go. We just do that, and it does its thing. Now, just to unpack what happened here a bit from the output, the MS build stager already contained like the URL that you needed to call back to. So like you really just need to execute that command. Once it does that, it performs the key exchange. It derives a key. It downloads the encrypted zip file. Because IronPython and Booleang require some DLLs that are not installed on Windows by default, it needs to resolve those somehow. Those DLL files are in the zip file that it downloads, so it just automatically resolves those from the zip file, and then it starts a Python file within the zip file also, which is the actual main stager logic.
And Marcelo, it does all that in memory, right? These DLLs are loaded into memory, not on disk.
Yeah, exactly. This is all in memory, and we're gonna. There's some downsides to that when you're talking about .NET stuff, and we'll talk about that after I just show you some modules. So once we get a stager going, we got a new session, and from there we could just go over to the sessions menu, and we got we can just list them out. This is somewhat new. You can actually get a lot of information. So when the session actually calls back, it just gives you a bunch of information. So if you're used to Empire or Metasploit, it's similar to that. And it gives you sort of process information, domain, all that stuff. And then you can actually run modules. Now, with the new update, since it integrates Booleang, there are now IronPython modules and Booleang modules, which is really cool because now you can interact with low-level Win32 APIs, such as mini dump, write dump. So the mini dump command here, I'm going to show you that in a second. That essentially just creates a memory dump of the LSASS process to disk, plain and simple. And this is useful for getting around some Mimikatz limitations or just for more AV evasion. Let's for example, let's execute the shell command. How about that? So you go over to sessions, the shell module, set the command to, just like a stupid example, like who am I / groups. How about that? Okay. So we got that. And then this is where the auto completion comes in handy, because you previously had to type out this long string, which is not ideal. So now you just give it the first string and it just auto completes for you, which is fantastic.
Nice.
And there you go. So it sent down a Python file which contained all of the logic to actually start a process up, get the output, and send it back. And after it does that, it just sends it back and then decrypts the output, and there you go. So that's the output of the who am I / groups command. But now, since we have
Marcelo, those commands are still run like on the domain. Like if you're monitoring Active Directory, even though programmatically it happened very different on the host than normal, in Active Directory you're still seeing that someone queried a group or whatever.
Yeah. Well, yeah, exactly. Absolutely. Definitely. This right now is just running the who am I command, but like if you did something like netview or netuser / domain or whatever, yeah, definitely. Like you would still see that query happening. Absolutely. But yeah, you can do like a lot more interesting stuff because you have access to all of the capabilities that PowerShell would have, right? So like you can inject Mimikatz, for example. Or let's try, how about internal monologue? How about that? And I think I showed this last time too, but it's just such a cool attack that it'd be worth showing again. So internal monologue basically just grabs the net NTLM v1 or v2 hash, depending on if you're admin or not, of the current user or of every user logged into the machine, depending if you're admin or not. So once we got that, tell it to run. And there you go. So that's actually, I'm not running in an elevated process, so I'm actually going to start up a new one running in an elevated process, so I can show you Mimikatz now. But that is my net NTLM v2 hash. And let's just start up PowerShell here as administrator. And this is, by the way, like I'm running this with Windows Defender on. Let's go over to virus threat protection settings. So the only thing turned off is automatic sample submission because I really don't want my malware being sent to Microsoft. So, and this is really small again.
That's what she said.
There you go.
Mm-hmm. Sorry.
Oh.
That's also what she said.
All right.
If you're playing along at home, that's 2. That's what she said in this episode.
In this, yeah, there you go.
Maybe 3. You might have one in the beginning of the show.
So now we got another session here, hopefully. Yes, there you go. So we got another session here that's running in a high integrity context. Sort of like Empire, like it'll put an asterisk if it is running in a high integrity context next to the username here. So that's that comes in handy. So let's head over to the Mimikatz module here. I use Mimikatz. And run that. And we're not, oh yeah, that's because I didn't run it on the right session. That helps.
Oh man, demos.
Yes. I mean, live demos are always great because you run into this stuff. And there you go. So now we ran Mimikatz on the machine. And as you probably noticed, like Defender didn't crap his pants because it didn't detect it at all. And we got all of the plain text passwords that we want. Now, one thing to note here is that if you run the PowerShell stager, Windows Defender now just detects. So like if you touch LSASS in any way from any PowerShell process, Windows Defend automatically flags that as a behavioral thing, as a heuristics detection thing. So you really have to take into consideration like what stager you use. All the PowerShell stuff that's currently implemented in Silent Trinity is there just for posterity's sake and just to make things a little bit more convenient, because technically by using PowerShell, you're sort of defeating the purpose of using this tool in the first place. So there's that. And you can also now you can also inject shellcode, do a bunch of stuff with WinRM, which I'm actually sort of still working out the bugs there. But technically, you can use that to move laterally with PowerShell remoting. There's a bunch of stuff that I'd like to see implemented in here as well. Also, if you're familiar with the execute assembly command in Cobalt Strike, that's essentially what this does. It just runs a .NET assembly. And again, this is all possible because all of these languages are interoperable with each other, because you can run C# within IronPython, within PowerShell. You can do all of that good stuff. And just to show you, I guess, a visual, so I'm going to run the mouse shaker module in Booleang. It's a Booleang module that just shakes your mouse, because why not?
Everybody needs their mouse shaken.
Yeah. And also, I'm sort of preparing for RMCCDC, so I'm running a bunch of troll modules for this, just so I can completely wreck everybody.
This is a great CCDC set of
Yep.
nodes. Shaking the mouse could really suck.
Yep. And just remember, just wipe their VMs and install Red Star.
Right? What is Red Star?
That's the official Chinese Linux distribution.
Oh, yeah.
Or was it North Korean?
Something like that. It was North Korea, I think.
Look at his mouse pointer go.
Yeah, so there you go. So now you got the mouse shaking. And again, this is possible because with Booleang, you can inject really, you can call low-level Win32 API calls. Just it's like the DLL import. If you're familiar with C#, it's the equivalent of the DLL import attribute that you can use in C#.
Now, are there any issues? So I did some testing on this using command.exe as well as PowerShell, and found that it worked pretty well for things like Mimikatz and whatnot. But if you run into some of these modules that would not work unless they're run inside of PowerShell.exe?
Yeah, so right now, so the way Silent Trinity resolves the assemblies needed in order to do everything, there's actually a bug in this version. I fixed it, but I just have to still work out some kinks. There's a bug in the version on GitHub that fails to resolve some PowerShell-related assemblies. So if you try to run the PowerShell module right now, it won't work because it just says I can't find the PowerShell module, the PowerShell assembly that I need, so it just craps out. But I fixed that. I got it working. The thing is, I also want to implement the functionality of running IronPython engines within different .NET app domains. And what I mean by that, if you're not familiar with C#, I'm going to show you that right now because I think it's pretty interesting. So let me minimize all of this. So let's take a look at Process Explorer here. So whenever you start a process that uses .NET in any way, you automatically load a default app domain. So an app domain, you can think of an app domain just like a box. Whenever you try to load any sort of .NET assembly /DLL, .NET automatically puts those DLLs inside that box, so that for performance reasons, because otherwise you'd have to keep referencing the assembly on disk all the time, so it would just be an enormous impact. So it automatically puts them in an app domain, and you can query, if you have administrator rights, you can query that app domain for all of the loaded assemblies. And this is sort of a detection mechanism right now, because through stuff like ETW, which is event tracing for Windows, or through some PowerShell scripts that have been put out recently, you can actually go and query for these loaded assemblies. I don't know if there's a way of making this bigger, unfortunately, but if you click on the process in which Silent Trinity is running right now, you'll see like the actual name Silent Trinity, the assembly that's loaded. You'll see like a bunch of you'll see like the Sharpsploit library, which is what Silent Trinity uses to load Mimikatz, and a bunch of the IronPython assemblies as well. Now, this is sort of, because there are no optics in .NET right now, there really isn't a good way of collecting this information at scale. So all of the stuff that can be used to like enumerate these assemblies in memory is sort of like, it's like really hacky and like it's not something that you can use in an organization. So like you can't collect this information at scale. And this is one of the detection mechanisms. The thing is also, but like you can load an IronPython engine within a separate app domain. Technically, I've run into a bunch of bugs trying to do this because this area of IronPython has not been fleshed out as much as it needs to be. And you can technically load IronPython in a separate app domain, which gets unloaded every time a module executes. So you wouldn't see like the Mimikatz assembly being loaded. You wouldn't see like the Silent Trinity assembly being loaded because it's just in a separate app domain, and which gets completely destroyed and garbage collected after it executes. So you basically only see the assemblies there running for as long as a module executes, and then it gets completely destroyed afterwards. And that's just one detection mechanism. Like there are a bunch of others. Like I think right now this is sort of the main one because, so yeah, like if we go back to the slides here. So right now because there isn't a lot of there aren't any these optics that we need in order for like security solutions to actually dig into .NET Framework and see what if there's any malicious code running, right? Like all of the solutions right now are sort of iffy at best. Like so .NET 4.8 does have AMSI integration, but it's in the really beta phase right now.
It has what integration?
AMSI. So like the same technology that sort of tries to detect malicious PowerShell scripts. Microsoft has started introducing that into the .NET framework itself, so the underlying framework. Now, the problem with that is, there's a bunch of problems with that. The first one, in my mind, is that, like, so say that .NET 4.8, when .NET 4.8 gets released, most Windows endpoints will still have .NET 4.5. So it's like the same thing that happened with PowerShell, right? Like everything was running on .NET 2.0 or 3, which didn't have AMSI, and then .NET 4.5 came along, and Windows 10 had .NET 4.5 by default. So unless Microsoft forces an update on all Windows 10 machines, which it could, knowing Microsoft, that's definitely a possibility. Organizations would have to manually go in and update the .NET version on every Windows machine, which, I mean, could break some stuff. Technically, but I don't know. And plus I feel like that would be a lot of work. So I don't know. There's a lot of unknowns with that one. There's a lot of scripts that have been put out by Manifestation and Cobber.io, which work at SpectreOps, abusing ETW, which is like a low-level logging mechanism, which is basically the only way that we've found so far to detect this kind of stuff in real time. Crab's ETW is essentially like a C++ wrapper on top of ETW. So if you want to build a tool that collects this stuff, you can build it in C++, but the level of effort with that is somewhat pretty high.
Yeah, because then basically any program that's using the .NET framework is going to get logged by that.
Yeah, essentially, yeah. So that would be right now having crabs right now at ETW. Yeah, which, oh my God, yeah, don't even get me started with that.
Having crabs really would suck.
Crabs would suck, yes. But crabs. So this tool essentially is a good starting point for like actually building something that an organization could use to detect this type of tradecraft. But again, like it's just like a building block. It's not a ready to use thing. So you'd have to build it yourself, which, is possible for certain organizations, but I doubt a lot of people will be doing that.
Yeah, but then implementing it's one thing, Marcelo, and then parsing all the resulting logs.
Yeah, exactly. And that's another thing too. Like you get like log what's the technical term for it? Like too many like distinguishing like the actual signal from the noise, right?
Right.
Logs. Because a lot of things use .NET, like a lot. So there's that as well. Plus, there's like some code. There's this blog post that I found from Countercept, which is a MWR company, which did a nice blog post on Silent Trinity, which has some of these detection mechanisms that I just talked about. So I guess it's an interesting thing to look at. And Luke Jennings, who also works at Countercept, did an awesome Blue Hat talk about this kind of stuff in his Memory Resident Implants Code Injection is Alive in Loop talk, which is something to look at. So like in terms of detection mechanisms, really you have your only option as of right now is ETW. And using ETW, you can see like all of the assemblies being loaded in memory in real time, but that is also a fragile detection mechanism because you're essentially triggering on known malicious class names. So what you'll see with ETW, from at least my understanding of it, is just the actual class names of the libraries being loaded. So really all you need to do is, that's just signature detection at that point. You just change the class name and you're good. So there's that. Also, like not having an image backing. When you look at assemblies being loaded, they're like, you can tell straight off the bat which ones have been reflectively loaded in memory and which ones are not. So like having assemblies that don't have an image backing on disk is sort of like you can potentially use that as like a starting point for like an IOC. So like you have to combine multiple things together in order to really detect this right now.
Awesome. Marcelo, any closing thoughts?
I don't think so. I really encourage though, like people to look into .NET because it is freaking amazing. Like the more I learn about .NET, it just keeps blowing my mind. And
our listeners can find out more at securityweekly.com/BHIS. securityweekly.com/BHIS to get more information about this. We'll post all of the relevant materials and links to things on that page. Marcelo, thank you for coming back to Security Weekly and telling us more about how Silent Trinity works. It's pretty awesome stuff.
Anytime. Thank you for having me.
And with that, we will take a short break, come back, and bring in our next special guest. Stay tuned.